Alrighty. Um, this is something that happens every day, right? We've got batteries, we charge up. This is, by the way, is a giant capacitor. A millifarad that's like 22,000 microfarads, right? So it's fully 1,000 times larger than the capacitors we used in our lab. So it's possible that as this discharges, it's going to heat up this thermometer, right? Never mind, you have to heat up all the glass and all the mercury in the thermometer and all kinds of flaws. But let's just go with it because it's a physics test, right? Okay. A power supply of electromotive force and negligible internal resistance is connected, so there's no like resistors in series with that, to a coil resistance wire using an arrangement. Switch 1 is closed and later opened. Switch 2 is closed, right? So when they close it, an infinite current flows, so that's okay because there's no resistance, right? And so it charges up, right? And so we'll calculate the energy stored in the capacitor when it's fully charged. And that capacitor equation, where is that sucker? What is this? This is paper too, so it should be in with the regular stuff. The equation you want to use is that the potential energy is 1/2 CV squared, right? And our capacitance is 22 times 10 to the minus 3 farads. That's what milli is, and they will use these prefixes without explaining them. Okay, I'm trying to find where that equation is. It's in the data packet, I'm sure. Okay, so there it is, right? And then our voltage is, of course, 24 volts, right? So this one is hopefully we're good, right? Then it says the resistance of the wire, this wire here, right, is 8 ohms. The resistance wire. Determine the time taken for the capacitor to discharge through the resistance wire. Well, it'll take an infinite amount of time, right? Assume the capacitor is completely discharged when the potential has fallen to 0.24, so 1/10 of the original voltage, right? Okay, so we're going to use, step 1 is figure out RC, right? RC is equal to, well, what the resistance is 8 ohms, right? And C is equal to this, right? So figure that out. That's your first step. Second step is use this formula here. V is V naught e to the minus, and then this is time divided by, because that's our tau, right? Time divided by T with fancy hair, right? The tau. Okay, so the RC ends up being like 0.176 or something like that, right? And then plug that in. Our final voltage, this guy's going to be your 0.24. This will be the original voltage is 24, right? This will be 0.176. You can solve for the time, so show that. That, again, I think that's a pretty easy 3 marks. Happy hunting.